Hey everyone, how's it going? Hopefully you understood what we did last week. Now is the time to do actual forecasting. So now we are going to use case scenarios to practice what we learned and how it applies to forecasting. The first thing to set up the stage, we're going to do a case study, a full case study, but before we do, we need to set the stage for this. So here's the hypothetical scenario. I want you to look at the top right map image. Okay, so you live in Oklahoma City, which I've outlined here by a red star. It is May 23rd, 2016. Now, the Storm Prediction Center, highly recommend you look into Storm Prediction Center. They put outlooks 7 days out. And they put outlooks every day to outline potential areas for severe weather. Now, this is one of those outlooks. On May 23rd, they put this outlook. Now, everything in yellow, there's 15% chance of seeing severe weather, and everything in red is 30% chance of seeing severe weather. So, the scenario is you're wanting to go see severe weather, potentially tornadoes. Now, you could pick to simply drive west into the middle of this 30% risk area, and you're only driving 2 hours, roughly. Now, what you need to realize is this is a very large area of severe weather. You'll need to pick a specific place within that area. That's where forecasting comes in. Now, to see tornadoes or even supercell storms, you need to pick a specific town, and we'll actually learn that we need to pick a specific time to be there as well. But for now, we need to narrow down this large area of severe weather to where we want to go. So in this case, or actually in most cases, the Storm Prediction Center outlook is fairly useless for storm chasers, or for forecasters, for that matter, because they depict a very large area. So for our purposes, we need to pick a specific town where you would want to head on May 24th, so the next morning. So what you would do as a good forecaster, you would go to bed on May 23rd. You wake up in the morning, you would look at the 500 millibars, which we learned last week. So here I pulled the 500 millibars at 12Z for May 24th. 12Z, if you remember, is 7 a.m. Central Daylight Times. So here we're going to conduct our basic analysis. Our upper level lows. I see an upper level low here because of the counterclockwise circulation. And I see another upper level low pressure here because of the counterclockwise circulation. Now we're going to find our troughs and ridges. In this case, there's a trough like this. And for this one, probably do something like this. No, like this, sorry. Now there is a clear ridge here, fairly obvious. Just like this. It's just to keep in mind. Okay, so what we know about this map is that southerly winds are going over the plains, moving north. Oh, in this case, it's not true, sorry. In this case, this side of the low would be cold convection. Okay. So, we have southerly warm air. And here is Oklahoma City. So we did our 500 millibar map. We can see that there's a trough here. It's going to eject or move downstream towards us. Pretty good severe weather setup. Now, there's one thing I forgot to mention last week is why are ridges and troughs important? Troughs means there's upper vertical lift in the atmosphere. This is very important because this means that there will likely be cold fronts, some kind of fronts ejecting. There's going to be a tremendous amount of lift, vertical lift, into the atmosphere, and that means convection, instability, storms, essentially. Now we're going to go into more details of that next week, but for now, let's keep it simple. First thing you looked at your 500 millibars, you're like, okay, I confirm the Storm Prediction Center is onto something here. Now, what we need to do is we need to go into our surface maps. So, it's 7 a.m. on May 24th. You're sitting in Oklahoma City. You need to pick where you want to go. And hopefully, it's not too far away that you can drive. So, what we're going to do now is we're going to look at the 12Z 7 a.m. surface map. We're going to do a full analysis on that. All right, so here's the scenario. Now, I have printed all the maps for that day because obviously it's, it's in the past, but you would have the 12Z map. Here you go. So, what you will want to do is you'll want to do start with your isobars, lines of constant pressure, then you would do your low pressures or high pressures, then you would do your fronts, and then we'll do a moisture analysis. So we'll do that for this. I will fast forward this video because you should know how to do all of these things, and we're going to talk about the resulting product. Okay, now you've completed your 12Z analysis. Should look something like this. Just to recap, we have a low pressure at 1005 millibars. We have a warm front extending all the way into southwestern Kansas, and then a cold front in Oklahoma. and a warm front, and then we have a draw line in New Mexico. This is your moisture plume. I only highlighted the 70 dew points. Not too concerned about the rest right now because it's only 7 a.m. So you can see the moisture plume here. Now what I want you to do, I want you to take an orange marker or whichever marker you want really, and I want you to draw in that Storm Prediction Center outlook. Okay, in this case, oh yeah, and I want to point out here, Oklahoma City is, about here. This is your location. All right, now, here's one thing that I usually do. Depending on where I am or what I'm doing, sometimes I would just pick a marker and outline the state or the province I'm doing so it just looks, it pops out a little better. So this case, I'm just going to do it in black here. I'm going to outline Oklahoma. And these maps, they're going to get pretty messy, and it's normal. So I'm just going to do it for this map so you can actually see what I'm doing. Now I'm going to use the orange marker, and I'm going to draw in that 30%. You remember that 30% risk area? And it's going to be roughly something like this. Then I'm going to hatch it. All right. And I'm going to name this my target area. All right, it'll just be like a rough ballpark of what I'm looking at. Okay, so now we did the 12Z map, and we can already say so much about this map, and I hope you see it. You need to be able to identify these features, and here's how you do it. I'm gonna go through this map in detail because this is important, but the other maps I'm gonna expect you to know these things. Okay, behind the dry line, we said that this is really dry. There will be no storms behind this dry line. Therefore, you can take that out as your target area. Now, you need to do this in your head, but I'm going to do it like this for now. And you know what? I'm just going to take stickies. This is where the surface map becomes very, very useful because you want to eliminate, by the process of elimination, where you're not going to end up. Okay, so behind your draw line is out. Now, in front of the draw line, in front of a front, there's going to be lifting in the atmosphere, and lifting is going to occur. It's going to hit the front. It's going to cause vertical motion in the atmosphere, and that's going to cause thunderstorms. So everything that's in front of the draw line is good all the way to your point where you are. Okay, so we're going to take out anything that's east of you. Now, the stationary front, lifting is going to occur just north of it, pardon me, as the front is moving. So anywhere there's lifting atmosphere, you need to consider your target area, because just north of the warm front, there's going to be storms. On the cold front, there's going to be storms. On the warm front here, there's going to be storms. However, behind the cold front, there's not going to be any storms. So we're going to take behind the cold front out of your map. In Colorado, there is no fronts. It's behind this dry line. That's out. Okay, so now we've limited our map to parts of Texas in front of the dry line, to the risk area that the Storm Prediction Center had, and into parts of Kansas. Now, the next part, we're going to do the same exact analysis. This is what you would redo over and over again. And we're going to do it for the 15Z. And hopefully for the 15Z 10 a.m., we're going to be able to add more stickies to this map and eliminate potentially more parts of the map so that you would have a narrower and narrower target area. Okay, in the interest of time, I did the isobars for the 15Z. Now I'm going to fast forward and we're going to do the low pressure, the fronts, and we're going to do the moisture analysis again. Alrighty, so now we have our analysis. 15Z. A few things I want to point out. If we bring back our previous analysis, the 12Z1, I want you to realize that the draw line is now, the low has retreated west back into Colorado, and the draw line is now connected to the low. Just the two quick observations. The warm sector is fairly similar. Now, look at the moisture plume. This is a 15Z moisture plume, and it extends. Here's your OKC, and I'm gonna shade out Oklahoma again, so just see it better on the camera. Okay, you can see that the moisture plume is extending now into Oklahoma and parts of Texas compared to the previous one where the 70 dew points were not in the target area yet. So at this point, I do not see any reason for you to change your target area at this point, considering it is only it's only 10 a.m. We're going to draw in a similar target area. Again, this is based on the Storm Prediction Center, but I feel like this is still a valid target area, so we're gonna hatch that in. This is the target area from the Storm Prediction Center. Again, nothing has changed since the 12Z in 3 hours. Nothing drastic has changed. The only thing that's changed is that you can see that your moisture is now moving northward. Very significant moisture. 70s dew point. It's very high. And yeah, that's something that I should have probably mentioned, but I will right now. When you're looking at a sweet spot, you're going to do a square bracket here. So when you're talking about 65 to 75 dew point, it's very good for storms. It's basically a sweet spot is 65, 70, which we have here. We have 70s. That's why I outlined that. So usually if when you're doing your moisture analysis, most people will just stick to the 70. If there's a few 75s in there, I didn't even do them, and then you might do the 65 outline. We're going to do the 65 in the next map. And then for your temperature, you're looking at anything in the 80s and 90s is what you want to look at here. Now, let's look into our target area a little bit closer. Try and zoom in. So our target area here, we have 75 temperature over 69. It's fairly good. It's within our range. Up here, however, we have 66 over 52, 71 over 65, 73 over 68. You know, it's pretty good, but this northern area, north of the warm front, is not as good right now. But we're not going to omit it right now. It's only 10 a.m. However, you really need to start jumping in your car because you have a few hours of driving if you want to get there. So at this point, using the 15Z map, I think you would be confident enough to take your car, start heading towards western Oklahoma into your target area. And now we're going to do the 18Z map, which is the 1 p.m. map. And we're going to assume that you are now in your target area at 1 p.m. And now you will want to refine your target area to a very specific location. So the next map will hopefully tell us that. So again, in the interest of time, I concluded the isobars for the 18Z. It's now 1 p.m. and you're sitting somewhere in western Oklahoma. Now in reality, if you're in the field, you probably don't have a printer with you, so you're probably doing this map analysis on your computer or on your iPad or something. So we're going to complete the full isobaric analysis. We're going to analyze the map after. Okay, so now you've completed the 18Z 1 p.m. analysis. This is where you're sitting in western Oklahoma. Now the first thing you'll notice, where's my previous map, moisture plume is now well within the target area, going into Kansas now. Okay, I'm going to outline Kansas as well. Okay, and yeah, sure, Oklahoma. All right, so the first thing you need to realize here as you're sitting in western Oklahoma, the low pressure hasn't done much over the last, pretty much throughout the entire morning. So you can assume that the low pressure is probably there to stick for a while. What else? Our draw line isn't doing much. However, you can see that it's now advancing. The Texas border is right here, and you can see that our 18Z map, our dry line, is now advanced, as it's now into the Texas panhandle. At 1 p.m. it is getting closer to us now, and there is a bulge in the dry line. Now I'm going to use this. You don't do this in your maps, but the bulge means that the dry line is now, well, bulging significantly. It's advancing significantly compared to the other parts of the dry line. So that's something you should have noticed on this map compared to our previous map. There was kind of a bulge here too, and now it's very pronounced. Okay, so what about our target area? Now let's look closer into the warm sector. So you gotta get used to that term. The warm sector is basically anything south of the warm front. That's the warm sector. So you are sitting in the warm sector. Now, going back to our ridge, this means that you have southerly winds in the warm sector. And in this case, hitting the dry line. Alright. So now we're going to start looking into individual stations to see if we're still sitting in a good spot or if we need to move. Okay, so we got 86 over 64 in the Texas Panhandle. And I see something here that I think I missed in my analysis. There is a 44 dew point here, very low. We're going to talk about that. And here we have a 54 dew point. Here we have 75 temperature over 55 dew point. Here we have 79 over 63. You know, again, it's fairly good. Okay, down here we have 85 over to 58. But I want you to go back to this station here. So there's two ways you could have explored this station. You could have drawn your dry line all the way here, although I don't think that would be valid for just one station. In this case, how I would interpret this is that let's look back at our 15Z map and look at the station. This station had 57 dew point. At 1 p.m. it has 44 dew point. So obviously there is a decrease in dew point at that station. This, to me, I would interpret this as the dry line is surging through that station. Keep that into your back pocket, because that is a very good observation that most people do not pick up on. Okay, so now we're sitting in western Oklahoma. Now I see this dry line surge, and I know that that's going to cause forcing in the atmosphere right in front of it. So now we're going to take our stickies. I'm going to blow it out. So let's eliminate some areas here. So we know we're not going back east because no thanks, right? So I'm going to put all my stickies in the east. We don't even want to look at that. We're already in western Oklahoma. And we know that nothing's going to happen behind the dry line. So let's put some stickies there. And behind the low, don't worry about that. And it's too late It's too late for us to go to the north of a warm front, so we're going to put a sticky right there. So all we're left with is basically everything along the dry line now. It's 1 p.m. We need to start making some critical decisions on which town we're going to intercept storms. Now, it seems to me that you have several options here. 1. Stay where you are. 2. Go north. 3. Go south, right? So, do you want to go south into Texas, or do you want to go north into Kansas, or stay? It's a pretty messy diagram, but well, this is where it comes down to the experience of the forecaster. Now, I'm gonna guide you through this. This warm sector up here, I have 79/67. And then you have 79/60 over here, 74/59 here. So our north option is looking pretty good. I'm gonna just circle this like that. Okay, keep that in mind. Now let's look at the panhandle. Got 86/64. Wow. Try and zoom in a little bit more. So that's a good sounding. And then your moisture tongue here, basically I would circle all of that as well. Now let's consider our south option. Our south option, you have 80/69, 79/68, 81/65. Basically, you know, all along the dry line is also viable. So what do? Right? It's 1 p.m. You need to pick, either you go along the dry line here or you go north. Because where you're at, it's probably not going to happen, right? Because if you look back at your previous map, the dry line's not moving very fast, right? And I would suggest that you stick with the drawline bulges you see here, right? So realistically, you would have 2 targets in this situation. I would circle here. In Texas. And I would circle here. Now, why did I not include the Texas Panhandle? Right. Okay. So why did I not include the Texas Panhandle? I think you could include the Texas Panhandle in this case. However, let's look back at our previous map. You see this moisture tongue here. It's clearly moving towards the Oklahoma Panhandle, right? Let's keep our crayon there. You see? Okay. You see our moisture tongue is entering Kansas now. Here's where you make predictions. We predict that this moisture tongue will be in this target area, perhaps in this target area. You see where I picked this target area where the moisture tongue is. This is why I would not pick the Texas Panhandle. Not enough moisture. And from our previous map, our moisture tongue hasn't moved very much in the Oklahoma Panhandle. So now you have a conundrum. Do you drive north or south? And this key feature, this station, is getting drier. This is your key feature for this day. What this means is that the dry line will probably extend like this in the future. Okay? Which means our target area here is set in stone, almost, because the dry line will be here, storms will occur in this area. We're hoping by our 21Z, which is our next map. Remember, your maps are every 3 hours. And your southern option is very far away. There's no sign of significant dry line bulging or drying down there. So for all we know, the dry line might be stalled. It might not be moving. So our best bet is probably to start heading towards this area. Now we're going to do the next map, the 21Z map. And the 21Z map, I have the answer here actually. The ones I did verify, I circled my target area right here. Okay. So we're going to do the 21Z map, and the 21Z, by 21Z, it's 4 p.m. You know, you should be in your town. You should be in your exact location where you think storms will occur, because 21Z, 4 p.m. doesn't give you much time to move. So let's do the 21Z and let's see if we picked correctly. Okay, so here I drew my fronts, I drew my low, and I drew my isobars. This is for the 21Z, 4 p.m. Now, realistically, you would never draw this in the field if you're already chasing. So this is where you need to have this concept pretty much written down, and you would basically just look at observations in the field without conducting an analysis. So Oklahoma, Kansas. Now I'm going to conduct my moisture analysis. Okay, now we have conducted our moisture analysis. So let's bring back our previous map, compare. Here's the 18Z map. You can see that our moisture plume kind of retreated a little bit, but it has increased moving into Kansas, down into our target to the south. It's gone completely. Okay, now we expected the draw line to surge into the Oklahoma Panhandle. Let's look. Exactly. I mean, look at this. It's crazy. We expected, out of this one station, we expected the draw line to surge towards this station. The draw line surged exactly at that station. Not only that, but the pressure also dropped in this general area. The low pressure also advanced into Kansas. Probably a product of dragging the dry line. Makes sense. Warm sector is all the way up into Nebraska now. So let's draw our target area now that we had. Was something generally like this. I'm going to write this down as previous AT&Z target. Cool. Now is the time to pick a specific town. We're going to zoom into our target. So we're currently driving somewhere in this area. In our target area, we're now going to look at individual stations within that area. So up here along the warm front, it's hard to see on the camera, but if you have the map in front of you, you can see stations going like this. One like that. And then one here going like this. And then you have 84, temperature over 64. Then here you have 82 over 68. It's a very good station. Down in the panhandle, we have a 92 over trying to focus so you can see better. 92 over 59. Now we're going to take a look at it. Okay, this station on the 18Z at 1 p.m. At 1 p.m. this station was showing 64 dew point. Now it is showing 59. So based on our previous observations, this area, no good. Not a good area. Moisture is decreasing, which means the dry line is getting too close to that area. However, the dry line means that the dry line is surging towards the station. Okay, so we eliminated already this area. Here we have 67. You know what? If we know that the dry line is surging towards the station, we can assume that everything south of that, no go. So we're going to exclude this area. If the dry line is surging northeast, realistically there's going to be a lot of forcing right here. Now going back to our winds here, why did I do that? You see that the winds are changing here, the warm front, makes sense. There's a front there. So if the winds are changing, it's going to be veering here. Okay, I'm going to draw in black. The winds are going to do something like that, a little bit of a counterclockwise circulation here. So here I would take a marker, completely different marker, maybe a light blue one. Circle this area here. Hash that. This is an area of enhanced shear. Alright, erase all of this junk. Cool. So we know that there's strong shear here. We know that just to the south of it, there's forcing going to happen very shortly. So I think at this point, you would refine your target area, and we excluded everything to the south of this. And maybe later on we'd include this. I'm just going to include it for now. I'm going to refine my target area. put this here. I told you maps are going to get messy. This is my target area at 4 p.m. Now, this is still a very large area, correct? We're looking at Dodge City, southwestern Kansas, areas that I can't name, can't remember. Seems like a fairly large area. We're looking at an area from Dodge City to Garden City to Liberal City in Kansas. So we started off our day in Oklahoma City, and then we moved to western Oklahoma, and now we are in Kansas. We're sitting in the middle of this area now. It may seem very large, but basically, since we outline our area, this is where we want to sit. As soon as storms develop, likely on this dryline bulge, we will be in the right position to intercept these storms. All right, so here's a neater looking map that I did a few years ago. This is the 21Z map. It's not 100% accurate, but this is how I had my target area. And I even went further and I said, this is where the storms will fire. And if we look back at our messy map, I said storms would fire here, basically where the dryline bulge is. You see the surge? Good stuff. Now, you probably noticed that this is the May 24th, 2016 day. This is the Dodge City tornado outbreak day. Here is the verification. All the red dots are tornadoes. These tornadoes, you see all of them. And then this is Kansas. This is Oklahoma. Look at our target. Kansas. Boom. So here, on this example, I demonstrated that you can successfully pick a target area in the early morning hours based on only surface maps and the 500 millibar maps. I did not look at any models at all to do this analysis. So I hope that this tutorial proved to you how useful surface maps are and what we did. Because if you did this analysis, and obviously it will take several years for you to get down to finding all these little features, if you did this analysis on this day, you would have seen 11 tornadoes, including 3 tornadoes on the ground at the same time, and an EF3 tornado, in all near Dodge City. So, what we're going to do next week is we're going to do other examples, and maybe a winter example, maybe Eli. You'll have to stick by and see what happens. But there's one thing that we did not talk about yet is history of low pressures and history of fronts. This example was not a good example for this, but when you have all your maps, once you complete all your maps, so here's the 12Z1, here's the TZ21Z, okay. Here's all your maps. Now what you would do, and what we're going to do next week, is we're going to do a history of the low and how it's moving. And we're going to do a history of the fronts and how it's moving. We can do that easily. And that's one key feature. And we're going to learn how to identify what these gray area means, ongoing thunderstorms, etc., etc. That's going to be next week. But for this week, we're going to leave it at that. And I'm going to give you some examples, another case study. You're going to try it, try and pick an area. The main key feature is that you refine your target area on every map you make. And really the key note out of this tutorial here is that you need to do your fronts. You start eliminating areas where you're pretty sure storms are not going to happen. And then you start refining your area, your target area, by looking at individual stations. Now don't fool yourself. Anybody that tells you that they don't look at the Storm Prediction Center is lying to other people and themselves. Okay, the Storm Prediction Center has the best forecasters on the planet. It's well within why not? I started the first 2 years just looking at the Storm Prediction Center, and that was my target area. In fact, our first map, that's what we did, right? We had our target area as the Storm Prediction Center's outlook. That's how we started. So I suggest you do the same. Use what professional forecasters have, and then start refining your target area by what you know, what you'll learn from these tutorials. So on that, it's my hope that you understood most of this. It's a lot of information. There's a lot of tips in this tutorial. I suggest you go over it several times and you understand why I did every single thing I did in this tutorial. If you do so, I can guarantee you that you will see storms if you head out chasing. This is all you need to know to see supercell thunderstorms. That's all you need to know. You need to know that there's a front here. There's going to be lifting on that front. Now, based on your experience, you need to know, should I go on this side of the front, that side of the front? So these are the things that you need to practice. And the only way to practice is you need to do case studies. So we do case studies like this, and then we verify, okay, what happened and why did that happen? Oh, okay, right, nothing happened behind the front because it was too dry. There's no thunderstorms. Makes sense. Okay. Next week we're going to do the same thing, but I will try and introduce mesoscale analysis. So realistically, in the field, once you're in the field, then you narrow down your target. You're not doing these maps. You're looking at it in real time on the computer. So next week we'll be incorporating that basically. And then Mark Robinson in the last week is going to talk about using forecast models. So see you next week.